Okay students, we are in the last part of this chapter, polymers. Just revising what we learned in the previous class. We had dealt with condensation polymers, right? So which were, first one was the polyamides, nylon 66 and nylon 6. Then we had polyesters, where we had that terylene and or decron. Then we had phenol formaldehyde polymers like Novolac and Bakelite. And the last one was the melamine, right? So melamine, formaldehyde polymer. Okay, so melamine and formaldehyde. Okay, react this, you get a resin intermediate. This is an resin intermediate. Okay, now this will polymerize to give you so this is your melamine polymer, which is used in crockeries. Unbreakable crockery we get. For that purpose we use this polymer. So all these are condensation polymers. Next we'll go into copolymerization. This is copolymerization. Now, copolymerization is a polymerization reaction in which a mixture of different monomeric species are made to undergo polymerization, or they polymerize to give you or produce a copolymer. So what is that? A mixture of different monomeric species is allowed to polymerize so as to form a polymer, and that is called as a copolymer. Okay. Now you can use addition polymerization or your condensation polymerization to get this copolymer. So one good example is the polymer that is derived by combining 1,3-butadiene with styrene. Okay, so CH2 double bond CH dash CH double bond CH2. So this is 1,3-butadiene plus styrene. This is styrene. So they will combine and or polymerize to form CH2 dash CH double bond CH dash CH dash CH2 dash CH dash CH2 dash C6H5, or take it down. So this monomeric unit you will get, okay. And this monomeric unit, when you take n number of times, will polymerize. So this is butadiene styrene polymer. Okay. So this is your copolymerization, which is nothing but a polymerization reaction in which a mixture of different monomeric species are allowed to polymerize so as to produce a polymer called as a copolymer. So example, butadiene styrene polymer, where we use 1,3-butadiene with styrene to get this polymer. Okay. Next thing is rubber. You know, rubber is a natural polymer, and everybody have seen how or what are the properties of rubber. So rubber has elastic properties. It can be stretched a little bit, right? So it comes under that elastomer, right? So it's an elastomer, natural rubber. Now natural rubber is derived from latex that comes from the rubber tree. So normally what is done, there is a rubber tree. So they cut a wedge in the tree, keep a pot here, right? So the sap slowly goes on collecting. Now that rubber latex, this is your rubber latex. Now this rubber latex is a colloidal solution, okay? So it is white color, just like milk. So it is coagulated, and from that you collect the rubber particles to get rubber. Now rubber is nothing but a polymer of isoprene, or you can call it as rubber is nothing but polyisoprene. Now what is isoprene? Isoprene is 2-methyl 1,3-butadiene. Okay, so 2-methyl 1,3-butadiene. So you can write it as CH2 double bond C dash CH double bond CH2. Here you have a methyl group. So this is your isoprene or 2-methyl 1,3-butadiene. Okay, so polyisoprene is called as, or it is rubber. So structure, if you want, the structure is something like this: C double bond C dash CH3 dash H dash CH3 dash CH3. Okay, take this down. So take this down, you get CH3, which is linked to C, double bond C. Here you will get H, here you will get CH3 dash CH3. Similarly, this goes and attaches to another CH2. Okay, so this goes and attaches to another CH2, which is attached to C H3 double bond C dash H dash CH3. Okay, so this should be 2. So this is the structure of natural rubber, which is nothing but 2-methyl 1,3-butadiene. Now rubber is very soft in nature. Okay, so what happens is when you heat rubber at high temperature, rubber is very soft. Okay, and rubber becomes very brittle at low temperatures. Moreover, rubber has, it can absorb water. Okay, so, and also it is not very resistant to oxidizing agent. It can be attacked by other oxidizing agent. So all these properties of rubber does not help it, or does not help us to make better use of rubber. So what is done? Rubber is heated with sulfur at a temperature somewhere around 373 Kelvin to 415 Kelvin. So when you heat rubber with sulfur, extensive cross-linking takes place, and that gives, or it stiffens rubber or hardens rubber, and that process is called vulcanization. So, vulcanization. So what is vulcanization? It is nothing but rubber plus sulfur. Okay, heated to around 373 Kelvin to 415 Kelvin. So what happens? You get stiffened rubber. And the process of doing this is called as vulcanization. Why it is done? Because natural rubber becomes very soft at high temperature and becomes very brittle at low temperature. Then what happens? It can absorb moisture. That is, it can absorb water. And the fourth thing is that it can be attacked by oxidizing agents. Okay. So just to improve the properties or enhance the properties of rubber, the process of vulcanization is carried out, where we simply take rubber, add sulfur to that and heat it to around 373 to 450 Kelvin, so that the rubber is stiffened or hardened. Okay, and then it can be used for tires and this and that. There are many applications of rubber. Okay, so this is what is done. Okay, then comes the synthetic rubbers. Now, synthetic rubbers, are synthesized by man, and they have rubber-like qualities. Okay, so they can be stretched to double their length, and they can regain back. Elastic rubbers you have seen, which can be stretched to double their length, right? So they can get a stretchable quality. So you have quite a few synthetic rubbers. Okay, one of them is called neoprene. Now, polyneoprene is one man-made rubber, or it is a synthetic rubber. Now, neoprene is nothing but it is 2-chloro. Okay, 1,3-butadiene. Okay, so what was natural rubber? Natural rubber is 2-methyl 1,3-butadiene. That is natural rubber. And this is 2-chloro 1,3-butadiene. Now suppose if I take this CH2 double bond C dash Cl dash CH double bond CH2. So this is 2-chloro 1,3-butadiene. So make it to undergo polymerization, heated, so that what happens is you get a monomer like this. Okay, now this monomer if it repeats n number of times, and that is your 2-chlorobutadiene, which is nothing but called as neoprene. Okay, so this is neoprene. Okay, so this is one synthetic rubber. Like this, you have one more, Buna-N. Buna-N. How do you get this Buna-N? This is another synthetic rubber. Okay, so here also we take 1,3-butadiene. Okay, and use acrylonitrile. Okay, so this we take, and this, when you heat them, you get a monomer which will be CH2 dash CH double bond CH dash CH2 dash CH 1, 2, 3, 4, 5 dash CH dash CH. So this is your Buna-N, another synthetic or man-made rubber. Okay, so neoprene and Buna-N. So these are synthetic rubbers. So what is now natural rubber? Natural rubber is isoprene or polyisoprene. What is the formula or the chemically what it is? It is 2-methyl-1,3-butadiene. Then we have synthetic rubbers. First one is neoprene. It is 2-chloro-1,3-butadiene or it is polyneoprene. Then we have Buna-N. So next is we have to learn about biodegradable polymers. You know, all this polymers like polythene, PVCs, bakelite, this and this, they are not, they will never undergo biological degradation. So plastic, for example, if you keep it buried for several years, several hundred years, it will not undergo any degradation. So nature cannot decompose them. Therefore, they become a very big pollution hazard. So everywhere you are seeing now, plastic waste here and there, and they are all polymers. And due to the excessive use of these polymers, they are everywhere today, under the ground, above the ground, everywhere. Therefore, they have become a very big pollution hazard. Therefore, efforts are being made to create polymers which can be naturally degraded. So these are called as biodegradable polymers. One such is PHBV. What is this PHBV? PHBV is poly beta hydroxy butyrate dash co beta hydroxy valerate. Okay, so this is one of the biodegradable polymer. So how do you get this? It is got by combining 3-hydroxybutanoic acid with 3-hydroxypentanoic acid. So what is 3-hydroxybutanoic acid? So CH3 dash CH dash CH2 dash COH. Now this is your 3-hydroxybutanoic acid. Plus you have to take 3-hydroxypentanoic acid. Okay, and you will get, I'll write this down. So take this O out, remove this H, get O dash CH, take this down, you will get CH2, CH3 sorry, dash CH2. So this you take C double bond O, then take this O, because this H is going to take away this OH. So this carbon you write here, this take them down, this is CH2 dash CH3, and rest you can write as dash CH2 dash C double bond O. So this is the monomer you get. Okay, so this will repeat. N number of times, and that gives you PHBV, poly beta hydroxybutyrate dash co beta hydroxyvalerate. It is a biodegradable polymer. Okay, so we have almost completed the chapter. Okay. There is one more, nylon 6, nylon 2, which is prepared by the reaction of glycine with amino caproic acid. So you can get one more biodegradable polymer, okay, which is called nylon 2 nylon 6, with the help of by combining glycine with amino caproic acid. So like this, there are efforts being made nowadays to get biodegradable polymers which can be easily decomposed by nature. Okay. So this is the end of this chapter. This is a very small chapter. Now just to summarize the whole chapter, we started with the definition of a polymer, right? So polymer is a macromolecule which is derived by repeating the same, a structural unit called as a monomer. So poly means many, mer means units. So one that has many units is called as a polymer. Then we went on for the classification of polymers. So there were several ways in which these polymers were classified. So one was based on source. So based on source, we had three types. What are those? What were those? First one, natural, then semi-synthetic, and synthetic. This was the first classification. Then we had another classification based on structure. Based on structure it was. So based on structure, here also we had three types, right? So linear, branched and network or cross-linked it was called. So this classification of the polymers was based on structure. After that, on mode of polymerization. So classification based on mode. Here we got two types. One was called the addition polymerization. Addition. Next one was condensation. Okay. So this was the third classification. The fourth classification was based on the force that was, the attractive force that was there between the monomers. So based on intermolecular force or force of attraction. So here we have four types. First one was the elastomer. Second was the then we have thermoplastic. Sorry, yeah, second one was fiber. Sorry, so fibers they were called. Third was thermoplastic polymer, and the fourth was thermosetting polymer. So like this we saw four types of classification. So once that was done, we went into addition polymerization. In addition polymerization, we saw the mechanism. So addition polymerization takes place by the free radical mechanism. So what happens here? So alkenes or dienes or their derivatives in presence of a catalyst which is called as the free radical generating initiator, right? So basically we use various types of peroxides like benzoyl peroxide, acetyl peroxide or tertiary butyl peroxides are used. So and the free radical mechanism takes place by three steps: initiation, propagation, termination. So how a free radical is generated which attacks the, I think we had explained that using the ethene molecule in the formation of polythene. So how that phenyl free radical will attack the ethene molecule, and slowly the chain starts propagating, in the sense growing in length, and then it terminates by various ways. One of way was by combination of two long chains that can come together and they can connect. So that was free radical mechanism. Then we saw several types of addition polymers, like we saw the polythenes first. In polythene, LDP and HDP. Then we saw Teflon, which is poly tetrafluoroethene. Then we saw acrylonitrile. So these were all addition polymers. Then in the next class we saw the condensation polymers, especially polyesters, polyamides. Then polyesters. Then we saw phenol formaldehyde. Phenol formaldehyde polymers, right? So then we saw that in phenyl formaldehyde we had a novolac. Then we had bakelite.